Let's go to question number 41. White light is incident normally on the glass plate of thickness 0.5 10 to the power minus 6 meter with the refractive index of 1.5. The wavelength in the visual region which are not strongly reflected by the plate are. The range of the visual is from 400 nanometer to 700 nanometer. The light is normally incident on this one, and the light will reflect from the bottom, and due to the power difference, and we know the equation, the path difference 2 mu t into cos of r in reflection is equal to 2n minus 1 lambda by 2, and this is normal reflection, so r is equal to 0, so 2 mu t is equal to 2n minus 1 lambda by 2. In order to find the lambda, this becomes 4 mu t is equal to 2n minus 1 into lambda, and lambda is equal to 4 mu t divided by 2n minus 1, and mu is given 1.5 and the thickness given is 0.5 10 raised power minus 5 divided by 2n minus 1. Now, dear student, we have to fill n 1, 2, 3, 4, 5, etc. And we have to see that for the maxima to occur, n value has to be filled and lambda should lie between 400 and 700. If you take n3 and n4, you get two wavelengths. The one wavelengths come to be 429 nanometer and second wavelength comes 600 nanometer. And the correct option is option number 2. Question number 42 says the intensity of the light coming from one of the slit in Young's double slit experiment is 3 times the intensity from the other slit. The ratio of the maximum intensity to the minimum intensity in the interference fringe pattern will be nearly. These are the 4 options. And dear student, it is given that intensity of one is 3 times the intensity of the other, and intensity is proportional to amplitude square. Therefore, I1 by I2 would be equal to A1 by A2 square, or A1 is equal to root of 3 of A2. And to get the maximum intensity to minimum intensity, the formula I maximum to I minimum is equal to A1 plus A2 whole square, and in minimum A1 minus A2 whole square. Fill A1 like this, root 3 plus 1, root 3 minus 1 square. This comes to be 14. Therefore, answer is 1. This question number 43. In Young's double slit experiment, when a glass plate of refractive index 1.5 and thickness t is placed in the path of one of the interfering beams with wavelength 600 nanometer, the intensity at the position where the central maxima occurred previously is unchanged, the minimum thickness of the glass plate. Now, students, when we introduced a transparent sheet, then what happened? The whole pattern shift, and you know that if it shift to the new maxima, then n into lambda is equal to mu minus 1 into t. T is the thickness and mu the refractive index. And what happens? For the minimum shift, n should be equal to 1. So lambda become equal to mu minus 1 into t, and t you have to determine. So t is equal to lambda divided by mu minus 1, and lambda was given equal to 600 10 to the power minus 9, and the refractive index is 1.5 minus 1. So this becomes 600 10 to the power minus 9 divided by 0.5, and your answer become 1.2 10 to the power minus 6 meter, which is equal to 1.2 micrometer. And the correct option is option number 4. The question number 44 says, the human eye has an approximate angular resolution of 5 into 10 to the power minus 4 radian, and a typical photo printer prints a minimum 500 dots per inch, where 1 inch is equal to 2.54 centimeter. At what minimum distance should a pointed page be held so that one does not see individual dots? Now, dear students, let's search the spacing between the two dots. In 2.54 centimeter of the space, 500 dots are created. So this is the distance between any two adjacent dots. Now I has the resolution value given equal to 5 into 10 to the power minus 4 radian. Now it should be viewed so that they should not be merged. Let's say I is here and this become the visual angle. When this is exactly equal to theta, the object won't merge, but if you move away, then they will merge. So this distance is required d, and from angular theory this should be equal to x divided by d, and d should be equal to x divided by theta. What is x? 2.54 divided by 500, and how much theta is in radian? 5 into 10 to the power minus 4. So we have to solve it. So d comes to be equal to 10.16 centimeter. And the correct option is answer number 1. Let's move to the next problem. The question number 45 says that if the light from a galaxy observed on the Earth's surface has a blue shift, then the galaxy is receding from the Earth, is stationary, galaxy is approaching the Earth, or both 1 and 2. Dear students, we know that the change in wavelength is given by this relation, Doppler effect in light. Now, when the things are coming closer, the wavelength should reduce. So that is called the blue shift. So in this case, the blue shift is when the galaxy is approaching the Earth. So answer to this option will be the 3. And thank you very much for watching this video, and hope you will continue learning from the next video. Thank you very much.